Hello developers, let's start developing. 25th of December came and passed, so basically we have all the tasks of the 2023 Advent of Code available right now. I managed to get 38 tasks while the days were going on, but now that means that I have 11 more tasks that I need to solve. Basically, I have no stars on 17, 19, 22, and 23, and I only have a single star on 24, 21, and 18. We will kind of slow down, think about those tasks, and then come up with a solution and make some videos where we will get to solve them. So, first I'm gonna take on day 19, a plenty. So we're still on the Gear Island. This is our last task on the Gear Island, I think. Oh no, we're actually down in the desert island. But we have the parts and we have a system that we want to use to categorize our parts. So we have four categories that we're gonna use. Whether it's cool looking, whether it's musical, aerodynamic, and shiny, or the Xmas dimensions, so to say, categories. So we have then a series of workflows that will accept and reject the part. We have a set of rules, and so on and so forth. So we have these example input. So the input is kind of complicated, so a big part of our task will be actually to parse this into something useful. And we have, these are the parts, and we have their settings here. So this one has a value of X, value of M, value of A, and value of S, and so on. And we need to run it through some rules. For example, if we have this workflow, it has four rules. If X is bigger than 10, we are sending it to the rule to the workflow called 1. If M is less than 20, we are sending it to the workflow named 2. If A is bigger than 30, then reject it. And then we have the fourth rule, accept it. So the fourth rule is an unconditional rule. It will always occur, which means that we will need to somehow model this thing. So which means that we have, let's define a category that is an X or an M or an A or an S. And I'm quite sure these letters were totally randomly generated to spell Xmas. And then we have a rule. Maybe we want to have a class here. Yeah, I think I would like to have a class, but it's gonna, because that class will gonna have to have something like a method or something like that. And I will actually, since we're here, yeah, I'm gonna implement this kind of a thing that says parse. So this is a static method that will parse a line and return a rule. Which means that it might be useful to have a class called workflow, which will have, well, something like this, only a workflow does not consist of that. This is one part of the workflow and this is the other part of the workflow. So we have a name on the workflow and a set of rules. And that's what we want to do. Only public string name would work in C#, not in TypeScript. My apologies. So let's have this for now. This is it. And now, what do we do when we want to parse a rule? So we're gonna take this, and of course, we can use a regex for this because, yeah, let's just take all the rules first. So what is a rule? A rule is basically something that has some word characters, many of them, and then has that character, and then has everything, and then has that character, and then it ends. And we kinda need this part as one set and this part as another set of data. Actually, we don't need the braces. We can just use this. Yeah. So we have our name, which will be the name, and we have our set of rules, which will become the set of rules. Cool. So let's do this in our code. However, after that, we have something else that we're gonna leave for later at the moment. So let's do this once more with all of these. And it seems that we are successfully parsing out everyone. We won't have, for example, a rule that has a number in the name or something like that. So in our processing input, we can say, well, let line equal the first of the lines. And while the line is not empty, we're gonna process the workflows. Then we're gonna skip a line because our line is empty, and something like this. We're gonna parse out our what were they? Gears, parts. And after that, our code will be basically a random through. So let's see how much this works. I'll just comment this line. And so we are processing our workflows. We will have workflow regex. No, it's not that. It's this. Once more. Never type in a regex in your editor. Always paste it. So now we're gonna need to say something like this. Only I never like this format. I always like line dot match on that regex, and then we skip a parameter. That's the initial, so we have the name and we have the rules. So we will need to have that rules split on a comma because that's the rule separator. And now we have the strings that display our rule. And after that, we will say, yeah, map them using the rule.parse method. And this returns, this is a, come on, rules are any line is possibly undefined. We know it is defined. So rules is, yeah, and we know that Okay, we don't know if there is a match. Let's actually solve that. If if we don't have a match, invalid workflow definition. So now we can just say yes, deconstruct it into a line, and the line is a string, so this is a string array, so this is a rule array. So that would be great. And of course, we will have workflows, which is a workflow array over here. And to that, we're going to add a new workflow with the name and the rules. The workflow can just be an interface, I guess, but doesn't really matter. Actually, is this the best way to have workflows? This might be better because we are doing a lot of referencing to a specific go to that workflow. So we will can just say workflows of name is equal to, yeah, if we have a class, we can use it. So we have our workflows. Okay. Now the only thing missing is that we need to do this. I totally know that this works just as fine, but I'm kinda used to seeing this format that they're calling the rule parse method with this string. So what do we do now? And now we have two different types of let's say rules. So we have a qualified rules and we have an always rule, an unqualified one. This means that first of all, we're going to need to detect whether it's the one or the other. So if it's the one, that means that it has this character. So let's make a regex that will actually match the qualified rules. So it will have one thing that we are interested in that will be X or M or A or S. And it says I matched it. And then we will have another thing that we're interested in that will be this character or this character. And we're matching that as well. And then it's gonna have a number, possibly more than one, and then it's have a colon, and then it's gonna have some letters. So that thing matches our thing completely, and which means that we will also need to add this. And now that thing doesn't match, but don't forget that we already did this part and we have them separately. So unqualified won't match, but the qualified one will. So this is a regex that we will need to do. Yeah, that is a regex, but we don't want that regex, and this is the rule regex. The qualified rule regex, but we can live with it. So we can say if no const match is rule regex dot match it on the line. And now we actually have to say if this thing doesn't match, it's not an invalid rule definition. And moreover, I will define some more classes here. We will have yeah, the constructor doesn't really make sense, but this will have a target workflow, target, which is a string. And I will also add something like public read-only string kind. Of course, like this. And now this says this has no initializer, but I can define this as an abstract thingy. And now it will say, well, the class is not abstract. Well, now it is. So the point is that now we modified our rule class that is just a template. You cannot create a new rule class. However, you can create an everything rule class. So this only is used for that static method. But this is an actual thing where it will define that we have read-only kind that is everything. So this actually works, and first of all, of course, we need to call the super to construct the rule, which is doing nothing, but that is a convention that we have to follow, and that's about it. This thing has a target. And we also might want to have another abstract method, whether something matches or not. No, and what we're getting is gonna be a part, because a part is something that has an X and an M and an A and an S. Yeah, we could have done it, define it differently. So this will have a category, which is a category, and the value, which is a number. Actually, this won't be doing that. It will take a part, which is a part, and yeah. So if it matches, it returns a boolean, and which means that we also might want to have a target here. Which means that, yeah, we always want to have a target, and this now will need to implement the matches up method, and it will definitely implement it like this, because the everything rule matches everything. And this is kind of common thing to do in a routing, for example, to have, if you have a routing table and you have a route for this, route for that, route for that, route for that, and at the very end you have a route that accepts everything. That's usually, for example, the 404 route. So if you go to, I don't know, GitHub, and this takes you, this route actually matches with the everything route. And the default handler for the everything route is a very nice looking 401, 404 page. So we're not getting a ugly message from the browser that this was not found. We are getting some information from GitHub. So we have our everything rule, and of course we're gonna have to have our qualified rule. Let's see what it says. We have a read-only target, read-only category. Yeah, this thing will have a category, and this will have a value, and it also needs I will write it like this because it has a category, it has the other thing, and it has this thing, which we can model with a boolean because we only have those two options, I guess. We don't have inequality, we don't have other things, but let's check it once more with the text of what is a rule. Condition. What is a condition? We actually don't have a definition of what is a condition, but from everything I saw, all the conditions are those two options. Let's see what happens if I remove these things, which match anywhere. I honestly don't see any rules that we are not matching. Anyway, back here, so we're gonna need a direction. Let's call it, which will be, yeah, it will be that or that. And now we will need to do the matching, and the matching says if the category is X, return whether the path, well, we will need to say if direction is that, return that, else return this. Not the most elegant code. We could have done it a bit simpler, a bit shorter. Actually, not a bit simpler. It won't be simpler, but it will be shorter. Because we can say something like part of category. Yeah, let's do that actually. Is less than this dot value. And we need to return that. Else, we need to return this. Yeah, this is better and it's not less readable. So this looks like it will work. Now we just need to say if this doesn't match, well, return new. Notice that we cannot say new rule, but we can say new everything rule with the line given as the name of the rule. Otherwise, we need to take the things that we actually matched. And we matched that thing, we matched that thing, and we kind of need that thing as well. And also that thing. So, x bigger than 10, go to 1. X less than 20, go to 2. So we have ignore the ignore part, and then we have the category, and then we have the direction, and then we have the value, and then we have the target. All of them are strings, and we will want to have them lined up here. So first of all, we need to specify what was the constructor we accepted the target. We don't need to do anything to the target. Then we need the category, we need the direction, and we need to parse out the value. And of course, the only thing that's different is that it needs to be a qualified rule instead of a rule. And this is not line.split, it's line.parse. match rule, rule regex only. We're not gonna use it. The rule regex, we're gonna say, yeah, that's the. Oh, we don't need this. We already matched it. It's just the match. We need another comma here, and then we kind of need a console log here. Let's see, this is the example input. Let's use it in the place of the example input and see if this thing happens. Okay. Start 19. Come on, come on, come on. We forgot a very simple part. Yep. Kill this. We need to move to the next line. So we stayed in a loop and processed the first line over and over and over again, basically flexing my bits in memory, and that would never have finished. But let's see what we have. So we have workflow and we have px has three rules. Qualified, qualified, unqualified. Yep, everything. PV, qualified everything, qualified everything, qualified everything, qualified everything. Seems that we have an everything rule at the every end. And let's just write out the px. To actually see the rules. And of course, the way the rules are written, they are basically by themselves a valid JavaScript, so I could just evaluate them. But I didn't want to do that. And it seems that here is where we goofed up. So, A bigger than 2006 and Q, KQ. We don't have a target. A bigger than, less than actually. 2006, this part didn't work, this part didn't work. Where did we mess up? We called super with the target, and that's supposed to get the target, set the target. And the value, let's add a 10 just in case. The direction seems to be okay. The value is not a number. Why is the value not a number? Let's see what we are matching. This says the value is 10. Did I mess those up? No, we have category, then direction, then value, then target. Category, then direction, then value, then target. 1, 2, 3, 4. And here we have target, category, direction, and value. Yep. One thing that sometimes happens. I think it should work now. It really doesn't. So let's start it like this and let's put a breakpoint here. The value and the target are wrong. The kind is correct, category correct, direction correct. Is it? This is A, this is M, and we in the input we have that's an A and that's an M. So we're going to here. What is the target value? Oh, it's undefined. A, and the value is not a number. So our bug is somewhere around here. Let's see. What is the match? What is the line? First, let's see. M bigger than 2090, A. So the category is M. This direction is that. The value is undefined. Thou shall never write in a regex, and thou shall always remember to paste the correct regex when you should paste it. The last two parameters were not taken because they were not captured in the group. And note that initially when we printed out our output, it seemed that everything was working just fine. Yeah, we got it now. We have the target, we have the value to 2006, 2090, and we have everything. Except the parts themselves. So now let's take a look at the other part of the input. And this seems relatively, or to be honest, totally straightforward. So it seems that this always has the format x equals some digits, comma, m equals some more digits, a equals some more digits, s equals some more digits. If they're always in this order, it doesn't make sense to actually implement any kind of validation that they're always in this order, because we can just, in this case, since this is all our input that we're gonna use anytime, we can just have that as part of the specification. So x, m, x, then m, then a, then s. And this has a item capture, four capturing groups, which means that we can just say lines.map for each line, and we can just define our part regex. So let's go back to the regex and add these two that I'm always more comfortable using, so I know that this won't run away and match something that it's not supposed to. So we can just say, yeah, something like this, and then we have X and M and A and S. And notice that actually Copilot finally understood that I prefer this format of parsing. And these are parts. So our actual input Yeah, this is an array of parts. What we will call our situation can be basically a set of parts, which are a part array, and a set of workflows, which are a workflow array. So instead of this, we can just use situation. Let's look the input now. Oh, and we actually need to return this here. Yeah, parts and workflows. Fortunately, we named them right. Is anybody complaining? Oh, that's not a workflow array. The second part is a set of workflow. We can immediately deconstruct it because we kind of don't need them together. We need them separately. And let's see if the parts are correct. We already established that the rules are most likely correct. Seems okay. 787, 2067, 2244. Yeah, seems okay. And now we just need to run them through the gauntlet. And what is the gauntlet? No idea. Let's see. So we're starting with which rule? All parts begin in the workflow named in. Do we have that here as well? Yeah, this is the in workflow. So what we need to do, so for of part of parts, let current workflow is workflows of, now the current workflow can be a string and that string can be in. So while current workflow is not A and the current workflow is not R, or we can just say call this VF index or VF name. So while that name is not accepted or rejected, we actually need to get the workflow. Next workflow is workflow rules. Find the rule for first, actually here. Find will just work just as fine, as that will stop at the first find. Within that workflow rules, find the rule which matches the part. When you find it, get the target. Since we know that all of them have a everything rule, that tracks, and then we move on to the next. And now, if it's A, we can just console log that part. Yeah, maybe all of them. M, comma, come on. Ah, S, and of course we're gonna have let add the count. That's 0. If it's accepted, we count it as accepted. Else, that is rejected and we don't count it as accepted, and we return the number of accepted. I think. Let's check this. 3 parts are accepted. Oh, we need to add everything together. And we're just piling it on, and then we're returning that. Let's see if this works. We might want to remove this thing. So, accepted, rejected, accepted, rejected, accepted. Accepted, rejected, accepted, rejected, accepted. And the total is calculated correctly. So let's see if maybe this works for the bigger input. As I said, the programming of the task itself took us very small amount of time, but parsing out of the input took us something that was substantial. So we're getting this number, and hopefully this number will give us our 40th star. We have no 39th star. Let's see, we got the 39th star. And to be honest, I already know all the second parts, even of the task that where I didn't solve the first part, because I read up on them. And so the sorting process is not fast enough. What do we want to do? We want to pre-compute everything so that we can just say this is accepted, this is rejected. So we don't want to basically run through all of the workflows because we already have a setup table. That part accepted, that part rejected. Because note that each of these is kind of splitting the world in two. So all of these with S over that, they're going to one pile, with S over that, going to another pile. And they say that all of them are numbers between 1 and 4,000. So this is simple. We're just gonna do a nest for nested loops and just move through from 1 to 4,000, and we're gonna brute force it, and it's gonna just take 4,000 times 4,000 times 4,000 times 4,000. This is millions, billions, 256 trillions operations. So that's quite a big number, which means that we will need to come up with a different solution. I think I know the solution and it's going to be a fun one, but for more on that in the next part.